So good morning everyone, and today I think is the last day for work, power and energy, and we will try to wind up this chapter as soon as possible. We were dealing with law of conservation of mechanical energy. We had seen some problems where we had applied the law of conservation of mechanical energy. Remember, the law of conservation of mechanical energy can only be applied when only what type of forces are present? What type of forces are present? Then only you can apply law of conservation of mechanical energy. Hmm? Hmm?
Conservative forces.
Only conservative forces should be present and non-conservative forces should be absent, or work them by them should be equal to 0. Now let us do one or two more examples. Question number 1. Let us say that I have a slide like this, and at the end of the slide I have a spring. The spring has a spring constant. Why I'm writing H? The spring has a spring constant of K, and I have a block kept at point, highest point. The height of this point is H, and this block is kept at rest at this point. Now, what I'm going to do is I'm going to let go this block. It will obviously come down. All the surfaces are smooth, so you don't have to worry about friction. What is going to happen is that it is going to compress the spring. You have to find out the maximum compression in the spring. You have to find out the maximum compression in the spring, and I'll give you 2 minutes to do this.
Sir, it is under root. Hello, sir.
Yes,
Under root 2 mgh by k, sir.
under root 2 mgh by k. That looks correct. How did you get this answer?
Sir, here kinetic energy of the block is transferred to the spring to compress. So final velocity of the block is under root 2 mgh after conserving gravitational force, and it will be transferred for the spring.
Correct. I mean there is no friction here, so you can straight away apply the law of conservation of mechanical energy, or what I call LOCME, from point A to B. Now, when I'm talking about B, I am thinking that this block, oops, I'm thinking that this block has been compressed by a maximum distance of X, and this is the point B where it has compressed. So I can apply LOCME from point A to point B. Total mechanical energy at point A should be equal to total mechanical energy at point B. Now for gravitational potential energy, I am taking this point as 0. For spring potential energy, this point is 0. Do we understand this? Yes or no?
Yes, sir.
So at point A, what are the types of energy that I have? The gravitational potential energy is plus mgh, yes or no?
Yes, sir.
Kinetic energy is 0,
Yes.
and there is no spring, so there is no spring potential energy. That should be equal to the total mechanical energy at point B. At point B, the gravitational potential energy is 0, but we have spring potential energy, and that is half kx square. Yes or no?
Yes, sir.
Plus the kinetic energy at this point where it goes to maximum compression, the velocity of the block should become 0. That is what you need to understand. So the kinetic energy also becomes 0. This is a simple equation that can be solved. Yes or no?
Yes, sir.
So from there you can get the value of x as 2 mgh by k, and you take the under root of the entire thing. Do we understand this?
Yes, sir.
Yes or no? No or yes?
Yes, sir.
Anyone understands this? Okay. I'll give you 2 minutes to note this down. Remember questions like this. Let me know once you are done so that I can move on to the next question.
Done, sir.
Done, sir? Then there comes another question, sir. Same question in a different way. Now I'm going to release this block from rest from this point. You have to find out maximum compression in the spring. Can you do that?
Yes, sir.
The block is released from a height h. To find the maximum compression in the spring, you have 2 minutes to do this. Just do we have answer for this one?
Sir, is length of the spring is negligible, sir?
No, we will find out the exact answer, and then I will tell you what happens if the extension is taken very small. So, how do you done it normally?
Sir, here length of the spring is needed, no, sir.
No, length of spring is not needed. You don't have to find out you don't need the length of the spring. Shall I do it?
Yes, sir.
This is point A and this is point B. And this distance, the maximum compression is X. So I can apply lockmate from A to B. This is the point, this is the lowest point. I can take gravitational potential energy as 0 here. This is the point where I take spring potential energy as 0. I hope everyone understands this. So total mechanical energy at point A should be equal to total mechanical energy at point B. What is the mechanical energy at point A?
mgh plus x.
mgh plus x. What is the kinetic energy? Spring
0, sir.
potential energy, kinetic energy, both are 0. What is the mechanical energy at point B? What is the gravitational potential energy at point B? 0.
0, sir.
What is the spring potential energy? Half kx squared. What is the kinetic energy? 0. So I can write kx squared minus 2 mgx minus 2 mgh is equal to 0. This is a quadratic equation in x. From there you will get two values of x. You can take the positive or the negative value, and that would be your answer. Do we get it?
Yes, sir.
Now, in some cases, they may say that H is very, very large than the compression of the spring. If we take that case, then you can neglect this term as compared to your value of mgh, and in that case, your answer would be same as the answer you got in the previous case. Do we understand this?
Yes, sir.
So in that case, your answer will be under root of 2 mgh by k. But this is your exact answer, which comes in this way. Got this?
Yes, sir.
Everyone understands this?
Yes, sir.
I'll give you 2 minutes to note it down. Note it down. If you have any doubts, please ask.
Done, sir. Sir, it's done.
So this is the next question then. Two inclined frictionless tracks of inclination, theta 1 and theta 2. Theta 1 is less than theta 2. Meet at A. Two blocks of different masses are allowed to slide down from rest at the same time, one on each track as shown in the figure. Which is the correct option? Which is the correct option? It can have more than one correct options as well. It is a question that came in one of the previous JEEs. Think about it. Any answers? Which of them are correct?
Sir, it's B and C, sir.
B and C are the correct option. Yes. Why are they correct? C option is very simple to understand, right?
Yes, sir.
If you apply law of conservation of energy from A to B or from A to C, the equation would be same. Mass will cancel from both sides. They will both reach with how much speed? If I call this height as h, they will both reach down with a speed equal to root of 2gh. Yes or no?
Yes.
Now, then there are two options. Both will reach at the same time, or whether anyone will reach earlier. Now, how do you find which one reaches earlier? Which one has more inclination? Remember, and these are the small things that you remember. If you have, what is happening here? If you have, what is happening here? Why is okay? If you have a wedge that has an angle of inclination theta, and you place a block of mass m on top of it, the acceleration of this block downwards is always equal to g sine theta. Do we understand this?
Yes, sir.
If the angle of inclination is more, it will have more acceleration and it will come down fast. Yes or no?
Yes, sir.
Now, similarly, if you have, I don't know what is happening here. I am getting all these marks. If you again place this block of mass m here and I have a coefficient of friction as mu, then the acceleration becomes g sine theta minus mu g cos theta. These are the two things that you must remember because you can get a question based on these two quantities. Okay.
Yes, sir.
So the acceleration would be more. It also has less distance to travel. So this block or this body Q will reach earlier than the block P. Do we understand this?
Yes, sir.
So mark this and remember the 2 points that I have told you. Okay. Have you noted it down? Shall we move ahead?
Yes, sir.
Okay. The next heading and the last heading for this chapter is this. power. The last heading for this chapter is power. To write the heading and give me a minute, I'll just restart this. I guess something is not happening correctly. Let me restart this. Okay, so the heading that I have given you is power. That is the last heading. What do you mean by power? What do you mean by the word power?
Work done per unit.
Okay, power of a body is defined. Power is defined as rate at which work is done by a body. A rate at which work is done by a body. Anyone understands this? Yes or no?
Yes, sir.
Rate at which work is done by a body. Defined. What type of quantity is power? Power is a scalar quantity. Yes or no?
Yes, sir.
Power is a scalar quantity. What else we need to know about power? Now, whenever we talk about power, we talk about two types of power. The first type of power is known as average power. Average power. Denoted like this, P with a dabba. P with a dabba. Oops, something is not right. Average power, P with a dabba. Okay. Now, whenever we talk about average power, this average power is always between 2 points. So the formula becomes what's happening. So the formula of this average power becomes total work divided by total time. Do you understand this?
Yes, sir.
Total work divided by total time is your
Power.
average power. Not power, it is your average power. This average power is always between 2 points. Do we understand this?
Yes, sir.
This average power is always between 2 points. The SI unit of power is what? The SI
Sir,
unit of power is what is the SI unit of power? It's joules
joule
per
per
second.
second.
And
Joule.
that is known as
Sir.
beta what?
Watt.
If you have average power which is between 2 points, then you have instantaneous power. Instantaneous power denoted by the letter P. Now, when I talk about instantaneous power, it is the power at any instant. Do we understand this?
Yes, sir.
So instantaneous power becomes dw by dt. Do we understand this? Now this dw by dt force can be written as F dot dr divided by dt. I can write this dr by dt as v, rate of change of position vector, So I have one more formula of instantaneous power. The instantaneous power can be written as F dot V. So you can write it and understand it in this way. You can write it or understand it in this way. In both the cases, this is your average power. Do we understand this? Yes or no?
Yes, sir.
Average power is instantaneous power is rate at which work is done now. Okay. Now you can formulate a relation between average power and instantaneous power. How you can find out the relation between average power and instantaneous power? Average power and instantaneous power. So you can write this average power as integral of P into dt. P into dt. This is integral of P into dt. Okay.
Yes, sir.
Since it is integral, you can also write it in this fashion. Since it is integral, you can also write it in this fashion. Average power is the area under PT graph. If you get a PT graph between power and time, it is the area under PT graph. I hope we are all writing what is there. Yes or no?
Yes, sir.
Then we have the next point, and the next point is pretty simple. What we know is power is dW by dt. Power is dW by dt. So it is the slope of work time graph. At any point, if you find the slope, that will give you the power. Do we understand this?
Yes, sir.
Okay, so these are the things that you must remember. I'll give you 2 minutes to note it down.
Done, sir. We are done, sir.
Okay. This is the first question that you are supposed to do. Let's see who gives me the answer first. A car of mass m is driven with an acceleration a along a straight road against a constant external resistive force r. When the velocity of the car is v, the rate at which engine of the car is doing work.
Sir, it's option D, sir.
Option D. What is option D? How did you get option D?
Sir, force into velocity.
So what is the force?
Sir, here one is mass into acceleration and another is resistive force, no, sir.
Think again. Have you drawn the diagram? Simple mistake is going to cost you a lot, beta. Simple mistake is going to cost you a lot.
Is it B?
Yes?
Is it option B, sir?
Since it is not option D, it has to be option B, right? But did you understand the logic? It's not the right answer that I am worried about. Is the logic that you are applying is what worries me. If you draw the diagram, what is happening here? Okay. If you draw the diagram here, this is the block of mass m. It is moving with a velocity v. It has a resistive force r. It has an acceleration a. So the engine, if it is giving you, just a minute, I'm having all sorts of trouble today. So if the engine is giving you an acceleration a and the resistive force is r, what force is the engine giving you? That will be equal to r plus ma, not ma minus r. I hope you understand this. Because it has to overcome resistive force and also give you an acceleration. If I say this is the force it is giving, F minus R will be equal to ma. Do we understand this?
Yes,
Do we
sir.
understand this? Yes or no?
Yes, sir.
That is your force, and you multiply it by V. That gives you your power. Yes or no? No, yes.
Yes, sir.
Note this down. And I'll move on to the next question. Shall I move on to the next question? Shall I move on to the next question?
Yes, sir.
Okay. This is the next question then. This has come in one of the previous year IITs. So remember this. A wind power generator converts wind energy into electrical energy, and assuming that the generator converts a fixed fraction of the wind energy intercepted by its blades into electrical energy for wind speed V. The electrical output will be proportional to what? So remember, whenever we encounter such a question, what is happening here? Something is not right. Anyways, I'll have to continue the class, then I can do whatever I have to do. Something is not right. Okay. So remember, whenever you have a question where water jet is striking a wall or any fluid or liquid is coming out of a pipe, or in this case, where air is striking something or air is coming out of something or air is driving something, the force that this sort of body produces is not a single body. It's not a single body of mass m which is hitting some body and it is generating the force. Whenever such question comes, what you have to understand is the force that this generates will be given by this formula rho a v squared. That is one thing that you should remember. This is known as impulse force, or ejection force, or sometimes known as thrust force. So you might have seen these firefighters holding a hose of fire hydrant, and as soon as they open this hose, they will experience a jerk in the backward direction, and therefore two or three people actually hold that hose. Have you seen that?
Yes,
It's
sir.
because of when water flows out with a very high velocity, it will exert a reaction force on the pipe and the pipe will jerk backwards. Remember, this force is directly proportional to v square. If the velocity is very high, the force is very high. If the pipe is very big, again the force is very high. Density of water is fixed, so we can't change the density of water. But do you understand? That is why they experience this jerk. That is the force that water coming out or any gas coming out of any hose will exert on the hose. Do we understand this? This is the force that is exerted by this wind on the what should I say, wings of that windmill, and that makes the windmill or the blade of the windmills to move. So what is the power that it generates? So now the power it generates will be F multiplied by V. So it will be rho A V cube. Do we understand this? We understand this, bacha?
Yes, sir.
So remember, it will be proportional to V cubed. I hope we have understood this. Yes or no? No, yes.
Yes, sir.
Okay. I'll give you one or two more problems. Remember, whenever they are talking about work done or power in a time interval, they're always asking about the average power. Do we understand this?
Yes, sir.
Whenever they are asking what is the power generated now, then they are asking about the instantaneous power. We understand this?
Yes, sir.
Remember that. Do not forget it. Here is a question from one of the previous year JEEs. This one, a force applied by an engine of a train of mass something changes its velocity from 5 to 25 meter per second in 5 minutes. What is the power of the engine? I give you 2 minutes to do this. So what is the answer?
1 minute, sir.
Sir, it's 2.05 megawatts, sir.
2.05 megawatts. That is correct. How did you get it?
Sir,
Average power is total work divided by total time. How do you find out the total work? Total work
change in
is
kinetic energy,
taking
sir.
kinetic energy, half m v2 square minus v1 square divided by the total time. Remember, velocity must be in meter per second and time must be in seconds. They have given 5 minutes, so you have to convert 5 minutes into seconds. We understand this, yes or no?
Yes, sir.
That takes us to the next problem. I hope everyone is doing the problems, yes or no?
Yes, sir.
Next one, do it fast. I have to do 2 or 3 questions. If you can do it fast, we will be able to finish it. From a waterfall, water is falling at the rate of 100 kgs per second on the blades of a turbine. If the height of the fall is 10 meters, what is the power delivered to the turbine? What is the answer?
Sir, wait a minute, sir.
Should not take so much of time. Taking so much of time, probably you're not thinking on the correct line. Here, You can see mass is not given, but the rate of mass flow is given. If I talk about power, it will be mgh, the energy it lost divided by time. Yes or no?
Yes, sir.
You can write it like this: rate at which the mass is falling multiplied by g multiplied by h. Do you understand what I'm writing here?
Yes, sir.
This, oops, this is given as 100. G always everyone knows. This is given as this. You can put the values and get the answer. Do we understand this?
Yes, sir.
Remember, I'm trying to do all the types of questions that have come, and I hope that you can understand them. We got this, yes or no?
Yes, sir.
That is the next one in line. A particle moves with a velocity v, something with under the influence of a constant force. What is the instantaneous power developed? Two minutes you have. Yes, bacha. What is the answer?
140, sir.
140. How do you get the answer? You just have to take the dot product.
F dot V.
This will be dotted with this 10. Minus 3 will be dotted with this minus 30. 6 will be dotted with 20. Yes or no?
Yes, sir.
And you will get your answer. Everyone got this? Can I have raised hands from everyone? Okay, and this is the last question that we had to do. Well done. We have done what I had in my mind. Last one. A constant force F is applied on a body. The power generated is related to the time as.
But the question is not appearing.
Oh, I think I need to restart my system. Something is not correct. So as soon as the class is over, I'll do that. A constant force F is applied on a body. The power P generated is related to the time T as how much? Power is inversely proportional to time. No? Here there is no inversely proportional. To confuse you, they could have given inversely proportional. How are you going to do this? Power is F dot V. We understand this?
Yes, sir.
Dot product of F and V. Force is already given, so force is known. It's constant, it does not vary. The only thing is you have to find out velocity in terms of force. How do you find out velocity in terms of force? F is equal to ma, yes or no?
Yes, sir.
I can write force as m into dv by dt, yes or no?
Yes, sir.
If I integrate both sides, I will get m into v is equal to f into t, assuming that the body starts from rest, yes or no? Change in moment, the momentum or change in momentum is directly proportional to ft, yes or no?
Yes, sir.
So from here I can write this velocity as ft by m, yes or no?
Yes, sir.
So the power will become f dot ft by m. We understand this?
Yes, sir.
So the answer will be f square t by m. F is constant, therefore it is directly proportional to the time t. That is how it has to be done. Got it?
Yes, sir.
This was the last question. I had to do it. I could not postpone it because the next class we are trying to begin the next part, and the next part is known as center of mass. So I will start with center of mass and try to wind it up by in one class or two class, then collisions, then rotation, and we will have to get through this part as quickly as possible, because the more I teach, there is no problem. I can keep on teaching you and it will never end. So I'll have to finish it up so that we can move on to the topics which are easier and more scoring. So we'll try to wind it up, covering all the topics, covering all the questions which are likely to come in your JEE. Okay, so then I'll take leave from this class. In today's class, we had seen what is power, instantaneous and average, and we had solved some questions based on powers. I've already sent you the sheet. I don't know why the sheet is not available to you still. You got the sheet now? Okay, I'll find it out. Just not getting time to talk to anyone. So I'll find it out. I'll see you in the next class. Next class, that will be the next topic, center of mass. I hope don't have any doubts. If you have any doubts, you can always come. Take care. God bless you all.